So we're continuing on with Chapter 1, Section 3, using exponents. So using the order of operations, how would you begin to evaluate this problem? Well, I know that inside this parentheses, this exponent of 3 means use this base of a to the 4th 3 times. So that's what you see here in this slide, that you're going to take this exponent, which means use the base just prior to it, 3 times as a factor. So here's the product of factors. And using the product of powers rule that we learned, you keep the base of a and add the exponents. 4, 8, 12. So we get a to the 12th. So please write in your spiral the power of a power rule. When you raise a power to a power, keep the base and multiply the exponents. So now I have a power and another power that doesn't have a separate base on it. So it's not like a to the m times a to the n, what we did yesterday. There's not a second a here. It's a to the m raised to the m. So that's what makes it look different. It's a power to a power, or a power of a power. So we keep the base and multiply the exponents. So write that rule in your spiral. And now let's copy this example and do this one together. So 2 to the 4th raised to the 3rd. That's how you would read that. 2 to the 4th raised to the 3rd power. So my base would be 2, keep the base, and multiply my exponents using the power of a power rule. Keep the base of 2, multiply the exponents. 4 times 3 would be 12. So that would be 2 to the 12th. Please write the following problems in your spiral, and we're going to work on them together. Simplify each and write your answer in exponential notation. So that's the direction that we have to follow. So our base in letter A is 3. Keep the base, multiply the exponents. 4 times 2 would be 8. Letter B, 2/7 is my base, and it's in a parenthesis. You can see this parenthesis here. So I'm going to keep the same format as the original expression. Always a good idea to do that. 2 to the 7th, put it in parentheses, and my exponents, 6 times 4, would give me 24. So 2 to the 7th to the 6th raised to the 4th power would be 2 to the 7th to the 24th power. 2a is my base, not just a. 2a is the base, so I have to put that in parentheses. 2a to the 5th raised to the 3rd power. So keep my base of 2a, 5 times 3 would be 15. That is not the same answer to a to the 15th, because that 15 would only go on that a, not on the 2. So my base is 2 a's, not just the a. So you have to keep that one in parentheses. Now I want you to try a few of them on your own. There are 4 of them. Take a moment, copy them into your spiral, and do them on your own. Keep the base, multiply the exponents. We'll go over these in class. There's the 4th one. We'll go over them in class. So try those 4 on your own. We'll go over them in class. Going on, let's simplify expressions using the properties of exponents. Well, we know 3 properties now. We know the product of powers, the quotient of powers, and the power of a power. So we're going to use all 3 of those properties. So the solution to this expression, -4 to the 2nd times -4 to the 3rd, all raised to the 6th power. So we've got a product and a power to a power. So I'm going to do my innermost parentheses as it says here. First, multiply within the brackets. Well, it's talking about this one, this innermost parenthesis. Inside here, we have a base that's in parentheses, and we're going to have to do the product of power first. So keep our base of -4 and add our exponents. Well, that gets us to -4 to the 5th. Now, doing the last step, doing the power of a power last, as it says here, which that would be the correct order of operations, parenthesis, then exponent. Inside this parenthesis, there just also happens to be exponents. So you would do parenthesis first, grouping symbol first. This exponent would be last. So we're down to -4 to the 5th power, all to the 6th power. So raised to the 6th power. So keep the base of -4. 5 times 6 is 30. So do you need to have that parentheses on the -4? Absolutely, yes. Is -4 raised to the 30th power the same thing? This means do 4, only the 4, as a base, multiply that 30 times. So that's 4 times 4 times 4, and keep going 30 times. Make the answer negative. So this would be a negative value. This would say take -4. -4 times -4 times -4 times -4. 30 times. That would be an even number of negatives. This would be a positive value. So they are not the same. You have to pay really close attention to, is the negative included as the base, or does it mean make -4 to the 30th power, as you see here? Or take the inverse of 4 to the 30th power, or negate 4 to the 30th power. That's how you would read this expression. That has a negative value. Try the following, write your answer in exponential notation. Well, we'll do these together. So copy letter A, m to the 5th times m, all raised to the 3rd power. Well, I know that this is m to the 1st. So I'm going to do my product of power first. M to the 5th times m to the 1st. Well, that would be keep the base and add those exponents raised to the 3rd power. Well, now I use a power of a power, and that would be m to the, keep the base, multiply the exponents, m to the 18th. This one's a bit of a challenge because we have all 3 of our rules happening here. We have a product of powers. I'm going to do that one first in the numerator. So keep the base, add those exponents. 4 plus 3 is 7. We also have 6 to the 7th now raised to a power of a power. And we have a power of a power in the denominator. So that's 6. Keep the base, multiply 2 times 5. Keep the base, multiply those exponents. Now I'm going to do the power of the power in the numerator. Keep the base, 7 times 4 would be 28. And last, I'm going to do a quotient of a power. Okay, well that's keep the base, subtract those exponents. So I would get 6 to the 18th. So this expression simplifies all to 6 to the 18th. That was a tough one. Now let's tackle this one also together. And I really don't like when they use this symbol, so I'm going to rewrite it as 2a to the 3rd power. So I'm going to simplify this. I have a to the 4th times a to the 2nd. So I have a product of powers. So a to the 4th times a to the 2nd, that would be a to the 8th. Oh, a to the 6th, sorry, a to the 6th. Add those exponents. Ooh, careful. 4 plus 2 is 6. Raised to the 4th power. So I simplified a little bit my numerator. All over 2a to the 3rd power. That's not, that 3 does not go, that cubing does not go on that 2. That cubing only goes on that a there. So it's not 2 cubed as well, because it's not in parentheses. So my power to a power, this would be a to the 24th over 2a to the 3rd. Now what I can simplify here is my quotient of powers, and I get a to the 21st, because a to keep the base, subtract 24, take away 3 would be 21, and that too would still be down there in the denominator. My a to the 24th divided by a to the 3rd, if that was the only thing that I had in this problem, it would be a to the 21st, but I have a 2 down there in the denominator. Another way I could write this is I could say, oh, well, there's really a 1 in that numerator. I could say 1/2 and then put a in the middle here, a to the 21st. That's another way I could write that. But I definitely could not put a to the 21st down in the denominator. No, 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 no. It can stay in the numerator, or it can go next to the fraction 1/2. But that's as simplified as that one's going to get. That one was a tough one. So try the following problems. Write your answer in exponential notation. There are 4 of them. So copy these. Do your product of powers, then your power of powers, and sometimes you have a quotient of powers. So there are 4 examples. I'll move it up here. Copy all 4 of these in your notebook, and we'll do these together in class. Lastly, I would like to think about this question here. Suppose a can be any integer in the expression a to the 16th over 2. Will the value of the expression be positive or negative? How do you know? Well, I have a base of 16. And speaking of base, it's making me think about this song by Meghan Trainor. So I'm just going to play it here for a moment.
Because you know I'm all about that bass, no trouble. I'm all about that bass, no trouble. I'm all about that bass, no trouble. I'm all about that bass.
So we're all about that bass, in case you didn't get it. We're all about that base today. Yes, we are keeping our bases and adding exponents, keeping our bases, multiplying exponents, keeping our base, all about that base, and subtracting our exponents. That just made me think about that. So anyway, think about this last math thing. Will the value of that expression be positive or negative? How do you know? We'll talk about that in class 2.